Today we're going to be taking a look at the preview for Quiz 5 coming up. A little bit with graphing, a little bit with factoring, a little bit with roots, and a little bit of review to boot. So let's go ahead and get started. Graphing each parabola, name the vertex, and sketch the axis of symmetry. Okay, we have one in each of the three types of forms. When I'm going with standard form to find my vertex, now I could try to type this into my graphing calculator, get lucky, hope to find the symmetry while I'm scaling up and down in my chart, and do it that way, but there's a much better way. So when I'm working with a vertex in standard form, to find the x value of my vertex, it's negative b over 2a. Now again, to do that, I need to know what my a and b values are going to be. And so I get those from right here, and I go, okay, so it's negative b, so negative 2 over 2 times a, which would be negative 1. So my x is negative 2 over negative 2, because that's what 2 times negative 1 is, which would make my x value 1. Now this is just me. At this point, I'm going to tell myself, okay, let's pull the calculator out here, and let's get some assistance. So I'm going to type my equation in. Be careful that you type it in exactly the same way it is in your problem. And when I go to my graph, remember, my vertex value is always going to be in the middle. So in this case, my 1 is in the middle, and I see the symmetry. Notice I see the same values as I go equally away from my vertex. So I see now that my vertex is going to be at 1, 5. And if I want to, which is never a bad idea to do, I'm going to go ahead and write my other values into a quick chart here. So when I go to graph it, I have the points available to me right away. So negative 1, 1, 0, 4, 1, 5, 2, 4, and 3, 1. Get my nice curve, not V-shape, curve through there. And the only thing left I have to do then is to work on my axis of symmetry, which again is just x equals and whatever the x value of my vertex is. Okay? But it does say in the instructions we need to sketch it. So I'm going to put a dotted line at x equals 1, which again is a vertical line. It's my fold line that we talked about before, that if I were to fold my paper right now along that dotted line, I would get symmetry on each side. So that's what the axis of symmetry is for. Now the rest of these actually go faster. My vertex form, remember, is going to be my HK. But remember, when you're looking at this, this is the form that it's in. And my vertex is the HK, but it's the opposite of H. The opposite of negative 1 is 1. And then my K, I just keep the value. So 1, negative 3 is going to be my vertex. Now, to get the rest, there's a couple of things that I want to do. I'm going to go ahead and get this graphed before I do my focus and directrix down here. So again, when I'm graphing, and I can't think of why we'd want to do this any other way unless you're just doing the things mentally, which is fine. I would go back to my y equals. I would type this in. X minus 1 squared minus 3. Go to my chart. Make sure that my 1, negative 3 is in the middle. And see, that's why I like calculating it first, because now when I see it over here, I'm like, oh, I did do it right. So 1, negative 3. Now let's jot my other points down. So 0, negative 1, negative 1, 5. Write my other values in here. And then we'll just plot those. So we'll get those dotted in. Perfect. Get my curve working. My axis of symmetry is just my x value of my vertex, so x equals 1. And the axis of symmetry will always go through the vertex, so that's another clue for you whenever you're going to draw that in. But then comes the focus and the directrix. So, when I go to calculate those, I'm going to move this down a little bit, because I want a little bit of room to work with. I'm going to steal the top of my page to do this. When I'm doing my focus, because I have my a value, it's 2, so let me write those in here. My vertex is my h and my k. And my a value is the value in front there. So my a value is 2. When I'm doing my focus can be found, and it's a point at h k plus 1 over 4a. And again, this is on that tan sheet that you've been given, and you can use that on the quiz, but here it is for our purposes right now. So all I'm going to do is I'm going to fill in the information I know. I know that h is 1. I know that k is -3. And then I have 1 over 4 times a. Now here's the part that can get interesting. The 1's going to stay the same. But when I go to figure out this part, I would just deal with this part first. Okay, just deal with the fractional, getting it simplified. So here, I'm going to have 1 divided by, now be careful, 4 times 2. Because if I don't put that denominator in parentheses, well, let me show you what happens if I don't. If I just type in 1 divided by 4 times 2. Now, if you don't know that makes no sense as an answer, you're going to write that down, you're going to get it wrong. Because what's the calculator doing? The calculator does 1 divided by 4, and then does it times 2. Well, that's not what you want. I want this. So to get that again the way we want, we do 1 divided by, and if you want the denominator to be done first, you have to put that part in parentheses. And again, we want the fractions. So that's 1/8. Now I'm not done. -3 plus 1/8. One more thing to simplify, and if some of you can do it multiple steps at a time, that's okay. -3 plus, any time there's a fraction, put it in parentheses. -3 plus 1/8. In decimals, 1 -23/8. Sorry for the squeeze here on your paper. Okay. That's my focus. And again, if fractions don't bother you and you can whip through that faster, or you have a mixed number you put it in, like -2 7/8, that's okay. But if you don't, that's okay too. Directrix, that'll go a little quicker. We'll do that above our name here. So my directrix, its formula is going to be y equals, because it's a horizontal line. And that's going to be k minus 1 over 4a. Now if I'm paying attention, and I've already done my focus, I notice the only difference is one's plus and one's minus. Okay, so I'm not going to go through all of this again. That's silly. The only thing I have to do now is I'm like, oh, so this is going to be just this part, but it's -3 minus 1/8. So if I'm not sure, if I am, I'll just type that in as my answer. If I'm not, I'll go ahead and then a math, enter, enter, and I get y equals -25 over 8. And that's my directrix. But the formulas, again, both for my directrix and my focus, are on your tan formula sheet. So use those, but then just plug the numbers in and take little baby steps like we did here, and you'll be in good shape with that one. Then to our last form, move this back up, our intercept form. Again, to find my intercepts, I just do opposites on both of these. because my intercept form, if I were to write it out, oops, and I forgot my A here in the front. But again, it's on your formula sheet. So I take the opposites of both of these for my x-intercepts. So my x-intercepts are at -6 and +2. So I'll put those dots in. You're like, that doesn't tell me the vertex though. Not yet. If I want to find the vertex, I can do it one of two ways. I can either start at each of the dots and just start counting my way in towards the middle until they meet, and it looks like that's at -2. Or I can take those two values, add them up, and divide by 2. -6 plus 2 is -4. Divided by 2 is -2. And that would be the x value of my vertex. Now, that's not the end. If I want to figure out y, I need to take this 2, this -2, and plug it in for x. Now again, if you're not comfortable doing that in your head, we can always say, okay, 1/2 is 0.5, or I could do a fraction. Let's even do that. So 1/2 times -2 plus 6, because I'm just substituting my x value in for the x, times -2 minus 2. Okay, that's -8. So my vertex is at -2, -8. Put my third dot in there. Let's play connect the dots. Getting better at my parabolas as the unit goes on. And again, don't forget your axis of symmetry, which still, even in this form, is just the x value of your vertex. Get that drawn in. Okay, and we're set on the graphing. Those are the only types that can come up for you on these. And again, I just like showing all of my work with the different things. If you can do some of the things on the calculator or quicken a few things up here, that's great. So, okay, on from the graphing we go. Factoring. Ooh. Notice solve. Find x. Do not just put them in parentheses and be done, or you'll lose some points because you're not solving. This one, just a diamond. So I need two numbers that multiply to -20 and add to 8. I was giving you a second there to think about it, so hopefully you took advantage and think like your computer was broken or something. So what do we got here? Well, we know we got a positive and a negative. We also know that the bigger number is going to be positive, because when they add to +8, that would be the case. So let's see. Does 5 and 4 work? Yeah, no. What are other options? Let's see. 20, 5 and 4. What else? What else? 10 and 2. Ooh, 10 and 2. Okay, 10 and 2. Don't stop. Set them equal to 0. Add the 2. Subtract the 10. Bingo. And again, just take your time. And again, I know you're not going to have this tomorrow, but again, work through these with that and think it through. 3 terms, we coefficient of 1, just do a diamond. Okay, solve it from there. Number 5. Now number 5 could be a short problem if you think about it for a minute. So I'll show you both, but really this one should be simple, because if I look at my first and last terms, it should be apparent, oh, they're both perfect squares. Now if you still haven't worked on your perfect squares, you're going to end up seeing in a minute, this is going to take a lot of work. Well, what do I square to get 16? Well, 4. What do I square to get 9? 3. What's the sign in the middle? It's negative, so they both are. You're like, dang, Harty, that's pretty slick. Yes, it is. But it's only slick if you know your perfect squares. Since they're the same over here, I'm just going to set one of them equal to 0. And I'm going to solve this. I'm going to have what in this case is my one solution. I got a fraction, but that's okay. Now, what if I don't remember that? Is it doom and gloom and I'm screwed? No. What's going to happen is you're going to have to do slide and divide. In this case, that may not be fun. Because if you end up having to do slide and divide on this, okay, notice that's done. It's going to take us about as long to do one step as that whole thing took to be done. 16 times 9 is 144. Oh boy. I need to find numbers that multiply to 144 and add to 24. Are you serious? Yes, I'm serious. To make this kind of hit home a little further, if I were to list out all of the pairs of numbers that multiply to 144, this may take a minute. I'm even having to stop and think myself along here. There's so much of this. And I may have missed one in there, but even with that, think if and I'm doing that in my head, if you had to do it on the calculator, think how long that's going to take. Know your squares. Now, which one's going to add up to 24? Well, 12 and 12 does. Okay. So x, 12, 12. And since they multiply to a positive and add to a negative, it's minus and minus. Again, I'm not done. I know. Isn't that looking better? I get the 16 back in here that I originally slid down. Now I'm dividing by it. Reduce your fractions. If you don't know, let the calculator do it. Punch in 12 divided by 16 and hit math, enter, enter. 3/4, 3/4. Neither of them reduce. So since they don't reduce, swing them back to the front. And then we're going to see something that looks familiar. It's that. You remember back when we did it with perfect squares in like 10 seconds? Yeah, because then you just solve it, you're going to get the same answer. But, just know your squares. Okay, I'm done. Another thing I haven't been saying on this, I need to be saying it more. Golden rule. These three have anything in common? Better say yes. They all have a 3. Okay, so basically I'm taking a 3 out of each of these. And what's nice about this, I don't have to do slide and divide because now it's just x squared. I can just do a diamond on that and be done. Oh, the ease of knowing little things like the golden rule and your squares. All right, I need two numbers that multiply to -8 and add up to -2. Again, think about the clues. Multiply to a negative, negative and positive. Negative number they add to, this one's going to be bigger. But what are they? What was that again? Okay. -4 and 2. Now again, I don't set the 3 equal to 0. It doesn't have an x. But these guys each get set equal to 0. Okay, and I'm set. Did I mention anything about perfect squares so far yet on this side? Yeah, I thought I had. Two-termer. Two-termer. Difference of squares. Let's keep this in mind. Squares. You think you need to know your squares for tomorrow? Okay, I'm done. I know that's like the 15th time I've said it in 5 minutes. Okay. What do I square to get 25? 5. What do I square to get 49? 7. And since I'm multiplying to get a -49, it's one of each. Once I get this factored, then again, I'm just going to set them equal to 0. So I'll subtract my 7 over on this one. Divide by 5, and again, try to avoid the decimals. Like I said, I won't mark it wrong if you do, but I'm just saying. But again, on this section, when it says solve, you have to finish. You have to figure out what the x values are. If you just leave it in the factored form, you only get half credit on those. Okay. So all right, that covers half of what we're doing here. Like half, well, actually a little more than half in its own way, because these questions are kind of large. So to the back, solve using square roots, what we were doing in class yesterday. Again, I need to isolate my x squared term first. Again, not isolated yet. Don't do the radical until it is. Once that x squared term is isolated, like you would if you were solving for x, undo the squared with square root. And again, be careful. It's plus minus because there's going to be 2 answers with these when I have a quadratic. And if your radical breaks down, you have to do it. And I don't mean to like 5-point something. I mean, take that list of perfect squares, find one that's a factor of 28. Square root of 4 is 2. It's perfect. It gets out of radical jail. 7 still acting irrationally. Now I'm done. And again, you only get the tan sheet, so you're not going to have the squares and all this stuff on your quiz to use. You've got to know them. Know them. Know them. Okay, before you get rid of that 5, whatever's the furthest away, the plus one's further away, you got to get rid of that first. Then you can deal with the fraction part. Once I get that fraction out of there and I've isolated my squared term, now I can square root it. Now I can plus minus my answer. Now let me check, make sure. Not a perfect square that goes into 15. Let's see, 4, no, 9, no, nope. Done. Parentheses are in my way. Nothing else is, just the parentheses right now. So we'll deal with that first. Okay, whack those out. 16, perfect square is 4. Add the 3 over. Remember that plus minus is like a blockade. Don't put them together quite yet. We will in a minute. Notice no radicals right now. No radicals means I have free reign to actually get the 2 answers, and that's exactly what I'm going to do. I'm going to do 3 plus 4. I'm going to do 3 minus 4. I'm going to get 7. I'm going to get negative 1, and I got me 2 answers. This all should be looking familiar because these are different things we've done with the homework and with the notes over the past week or so. Same thing with 11. Area of a rectangle. Area is length times width. They tell me the area. It's 42. They tell me the length. They tell me the width. Doesn't matter the order I write them down. But now we're going to go along doing something like we did up here. We're going to distribute that x through. And I go, okay, well maybe not with the roots. Maybe factoring's the way to go here. Yeah, let's do that. Let's everybody hang out on the x squared side. So we're going to minus that 42 over. All right, so got this ready to roll. What should I do now? Should I slide and divide? You said yes, whack yourself in the head. Golden rule. Do all 3 of those have a number that divide evenly into them that might make this easier? Oh, by, yes they do. They all can be divided by 3. Gone from a slide and divide where I'd have to figure out factors of 126 down to a simple diamond, just because I followed the golden rule. That is the way to go. So I need two numbers that multiply to negative 14 and add to 5. Again, it's one of each. Bigger number is going to be positive. 14 is 7 times 2. Set those equal to 0. And solve them. Now, before you tell me that they're both values that work, think about it. Which one doesn't work? And why is that? Right, I can't have a negative side to something. That's silly. So x is 2, but dimensions of the rectangle. Literally plug the 2 in and tell me how big this is. Well, plug in x for 2, it's 2. 3 times 2 is 6, plus 15 is 21. Okay, got my dimensions. Don't skip them. Like, dang, Harty. An egg is dropped from a height of 105 feet. How long does it take for the egg to drop to the ground? Okay, remember, my h of O is going to be my initial height. And my ending height is going to be what's at the beginning. Typically, when it says the word ground, that's going to mean 0. So 0 equals, because it says how long, I don't know what t is yet. So I've got my height. I'm going to minus my 105. So again, my whole thing here is to solve for t so I can figure out how much time it's going to be before the egg hits the ground. Divide by the negative 16. And again, this is our opportunity to use a decimal, because we don't speak saying the egg will hit the ground after the square root of 105 over 4 seconds. Now, if you wanted to do that as a gag with somebody, that's all fine and good, but nobody else is going to take you seriously. So 105 divided by 16. So it looks like about 2.56 seconds. That's not very long. But again, I'm just solving, setting up with the equation I'm given, and then figuring out the time. And then finally, your favorite and mine, piecewise. Yes, yes. Remember, line. If I could make this word must about 50 times bigger than this, the whole screen, I would. Must start at x equals 4. Your lines have to start there. Not at 0, not at 8, not at some other random number you pick. Here. That's why with so many of you, I keep stressing the need to make a chart. Not a difficult thing. If I'm doing it here, where do I start my chart at? 4. What does this say? X is less than or equal to 4. What are a couple numbers that are less than 4? 3 and 2. Now, if you want to plug that into the calculator and look at a table to get these values, you can. I don't think that's necessary, especially with something as simple as just negative 2x plus 6. If I plug the 4 in, negative 2 times 4 is negative 8, plus 6 is negative 2. Negative 2 times 3 would be negative 6, plus 6 is 0. And negative 2 times 2 is negative 4, plus 6 is 2. Now, here is my starting point. Is my dot on here going to be open or closed? That's right, it's going to be closed. So at 4, negative 2, close dot. And we have 3, 0, and 2, 2. Start from the big dot, connect to the little dots. That one's done. Then I do the same thing with the other one. I make a chart. Where am I going to start at? 4. X is greater than 4. 5, 6. Now, if this one you're like, it's a fraction, okay, no big deal. We've got this. If we need to go to the calculator for a part, so here I'd have -3/4 times 4. Okay, so that one's -3. That came out nice. And all I'm going to do is take my time times 5 and finally times 6. As you can see, it's okay if we get some decimals. So once I've done that, last thing I got to think about is this one going to be open or closed? Open, not only because it's just greater than, but also we're only going to have one of each time. So 4, -3, we're open. 5, -3.75. 6 is about 4.5. Big dot connect to the little, and we're done. As I always say with this, if all you've done on this right now is copy everything you've seen from me, you didn't start any of it yourself yesterday, you need to either make a copy of this online and then try to do it yourself, or find some homework problems from these sections and go back and see if you can do them without any help. Because that's when you know if you're ready. If you can sit down and do all these types of problems without looking at your notes, without looking at the homework, without looking at a video, you're ready. If not, replay the video maybe, replay a video from the section you're struggling with, try some problems in the book or one of your homework assignments and do that. Good luck tomorrow. If you're prepared, I'm sure you're going to do great.